Hello. So in this video, we'll be talking a little bit more in depth of special right triangles, and we're going to be looking at the 30, 60, 90 triangle. So the 30, 60, 90 triangle is created through an isosceles triangle. And so when you have an isosceles triangle, if you draw this perpendicular down here, not only does it bisect the angle, but it also bisects these sides opposite that 30-degree angle. So we've got our 30, 60, 90-degree angle here. So what I'll do is just kind of to show you the relationship between the sides, I will call the side opposite the 30x. And because this is equilateral, this hypotenuse then would be 2x. And so what we're going to be looking for is this length opposite the 60. And so here I go. I will do the Pythagorean theorem. I've got x squared plus, I'll call it b squared, is equal to my hypotenuse squared. 2x squared is really 4x squared. So going through and solving for that side opposite the 60-degree angle, we get the square root of 3x squared, or the square root of x squared is x, so x rad 3. So what this tells us is that the relationship of the sides on a 30, 60, 90 triangle is actually x to x rad 3 to 2x. And so if you have one of the side lengths, you can generate the other side lengths using multiplication or division to bounce from side to side. So for example, we're going to look at the side lengths that are created when you have a unit circle. So here I'll just draw us a small little visual. My circles are not great, but so if I draw an angle in here, okay, um, and so because this is a unit circle, we know um, that this length would be 1, right? And then we've got our 90. So now all I have to do, guys, is generate the other side. So I'm going to say that this is my 30-degree angle. And I could get the other side length. So again, the ratio was x to x rad 3 to 2x. And so we have that this length is 1, right? So if 1 is equal to 2x, then that means that regular x is equal to 1/2. So the side opposite that 30 would be 1/2 in length. Okay, so now I have to get the side opposite the 60, which would be here. And so to get that, I would just do the x length and multiply it by rad 3. So that would be 1/2 times rad 3, or rad 3 over 2. So this length would be rad 3 over 2. Cool. All right, so what does this tell us? Well, it tells us a couple of things, especially if we use the fact that x is cosine and y is sine when we're looking at the unit circle. So if I wanted to know the sine of 30 degrees, that would be 1/2. The cosine of 30 degrees would be rad 3 over 2. And then tangent is sine divided by cosine. So that's 1 over rad 3, or if you needed to rationalize it, it would be rad 3 over 3. Okay, remember that not only do you need to know these as degrees, but it's also important to be fluent in radians. So I need to just, oopsies, be able to convert all of these to radians. So 30 times pi, and then I'm trying to get rid of the 180. 30 divided by 180 is 6 in the denominator. So I will have, this is really sine of pi over 6 is 1/2. Cosine of 30, cosine of pi over 6 is rad 3 over 2. Last but not least, tangent of 30 is 1 over rad 3, or rad 3 over 3. Yay.